Welcome students to this new video on differentiation for the class 12 students of Maths and Stats. We have seen already some examples from the exercise 1.2 up to question number 6. We have discussed many examples. I am now taking question number 7, where you need some trigonometric identities or trigonometric properties for solving these examples on differentiation. Here is one example you can see on the board. Cosec inverse of 1 upon 3 sine 4x minus 4 sine cube 4x. We have to differentiate it with respect to x. So what we do here is, first of all, we have to write it as y. Y equal to that given function, cosec inverse of 1 upon 3 sine of 4x minus 4 sine cube 4x. Here I have to remember one property. Which property? The triple angle formula. The triple angle formula, sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. 3 sine theta minus 4 sine cube theta, that is sine 3 theta. So it is 3 sine theta minus 4 sine cube theta. So your theta is 4x. So remember, this property will be used soon. Before using this property, we shall also require one property which will make it very simple. This example, I will write this example as sine inverse of, because it's in terms of cosec inverse. So it's always better to write sine inverse, cos inverse and tan inverse in place of cosec inverse, sec inverse and cot inverse respectively. So cosec inverse of some expression can be converted into sine inverse as, see this, 3 sine 4x minus 4 sine cube 4x. Now what is this? It's the property used here is sine inverse of a upon b is equal to cosec inverse of b upon a, and vice versa. So if you have cosec inverse of a upon b written as sine inverse of b upon a. B upon a means this will go up and 1 will come down, which is not mentioned. So we shall use that property. Sine 4x minus 4 sine cube x, as per this formula, it will be sine 3 theta. What is theta in this case? Sine 3 theta is this is 3 sine theta, so theta is 4x. What is it giving us? It is giving us sine inverse of sine of 3 into 4x is 12x, which means again another property, sine inverse. So that gives us sine inverse of sine x. Sine inverse of sine x we know is just x. Sine inverse of sine x is x. So sine inverse of sine 12x is just 12x. So y is equal to 12x. Now differentiating this example with respect to x, you will get dy by dx is equal to, what is the derivative of 12x? Remember always, derivative of constant into x, mx is m. M is a constant. So 12x is derivative. It's just 12. You don't have to think too much about it. So if you have a constant into x, you can differentiate it as equal to that constant. So its derivative is 12. Whichever way you want to remember, you can remember that. So what we do here in this example is, you can go through this quickly. Some steps are shown here and some formulae which we used. Now I am erasing those. This example starts with the original expression as it is, cosec inverse of something. Cosec inverse of a upon b can be written anytime as sine inverse of b upon a. So this becomes sine inverse of 3 sine 4x minus 4 sine cube 4x. Then the formula which we use inside this bracket, what was that formula? Sine 3 theta is 3 sine theta minus 4 sine cube theta. So that gives you sine 3 theta. So it becomes sine 3, this was your theta. So it became sine inverse of sine of 3 into 4x, which is 12x. Sine inverse of sine x is x. So sine inverse of sine of anything is that thing. So it gives you 12x. And then such a simple, it was originally, see how difficult it looked. This expression was very complicated in the beginning. It became just 12x. And then differentiating it with respect to x, you get just 12. So in this manner we can solve this example. Now consider this new example from the same exercise 1.2, question number 7. Sine inverse of 1 minus tan square 3x upon 1 plus tan square 3x. This is sine inverse of 1 minus tan square 3x upon 1 plus tan square 3x written equal to y. As usual, we write this as let y equal to this. Then we try to remember such expression. And I remember one formula which is 1 minus tan square theta upon 1 plus tan square theta. What is that equal to? Is equal to cos 2 theta. So if you remember, this 1 minus tan square theta is 3x in this case. So this expression is going to be how much? It is sine inverse as it is of what? Sine inverse of this is cos 2 theta. 2 into what is theta? Theta is 3x. So it gives you sine inverse of cos of 6x. Remember this? Just relate these two expressions and you would come to know what is done with the bracket, which is equal to sine inverse of cos of 6x. I'll just wait. Sine inverse of cos of 6x is a little bit odd looking expression. What I need is sine inverse of sine of something. So sine inverse of this cos can be removed as sine inverse of, if I want that cos of 6x changed into sine of something, what is that equal to? Sine of pi by 2 minus theta, in this case 6x. Sine of pi by 2 minus 6x is cos x. So always if you want cos x to be converted into sine x, just write it as sine of pi by 2 minus x. In this case cos 6x written as sine of pi by 2 minus 6x. If you want to convert cot into tan, cosec into sec, you just have to do the same trick. It's a relation between sine and cos. So what is remaining after that? Sine inverse of sine of pi by 2 minus 6x is just pi by 2 minus 6x. This property we have used so many times. Sine inverse of sine theta is just theta. Sine inverse of sine theta is theta. Cos inverse of cos theta is theta. Tan inverse of tan theta is theta, and so on. So this is why in the simplified form, now you can differentiate and get answer. Differentiating with respect to x, you get dy by dx is equal to pi by 2 is derivative, d by dx of pi by 2, which is 0, minus derivative of 6x is 6. Derivative of mx, remember it's always derivative of m into x, constant into x, is that constant. Like 3x's derivative will be just 3. 3 taken constant outside and derivative of x is 1. So like that we can write this derivative of 0 minus 6 is minus 6. So dy by dx is equal to minus 6. That is the answer. Okay. Let us consider this new example. To differentiate y equal to tan inverse of cosec x plus cot x. Now here again some trigonometric arrangement is required. These are all the examples in question number 7 which require trigonometric arrangements. So here we shall make those changes, cosec x and cot x. See, cosec x can be written as 1 upon sin x and cot x can be written as cos x upon sin x. So let's make that change and write it as tan inverse of cosec x means 1 upon sin x and plus cot x is cos x upon sin x. Now we can write these together, these two terms together, as 1 plus cos x whole divided by sin x. Understood? This is tan inverse of 1 plus cos x. Now there is another arrangement required here. 1 plus cos x, the half angle formula. You must know the half angle formula. 1 plus cos x is 1 plus cos theta is 2 cos square theta by 2. That can be used. And sin theta, another half angle formula. Sin theta is equal to 2 sin theta by 2 into cos theta by 2. These two formula are going to be helpful in this example. So time to time you require these formulas. So be careful about those formulae. 1 plus cos x using this formula will be 2 cos square theta means x here, so x by 2 divided by sin x is half angle formula 2 sin x by 2 into cos x by 2. Now this is going to be equal to tan inverse of, now 2 is getting cancelled with this 2 cos square x by 2. Out of that cos x by 2 and 1 cos x by 2 gets cancelled. So what does remain after this is tan inverse of 2 cancelled. Cos square x by 2 means cos x by 2 into cos x by 2. One of them is cancelled. One remains. So it is cos x by 2. One thing in the numerator now finished. Divided by denominator is sin x by 2. This is what remains. This is tan inverse of what? Cos x by 2 upon sin x by 2 is cot x by 2. Tan inverse of tan x by 2 would have been fine. Would have been what we have required. But it is tan inverse of cot x by 2. Still there is no problem. We can still manage it. And write that as y is equal to tan inverse of tan of pi by 2 minus x by 2. You can do this arrangement anytime, which is pi by 2 minus x by 2, because tan inverse of tan of anything is that thing. Tan inverse of tan of x is x, so that way. Now finally, differentiating this with respect to x, you get dy by dx is equal to pi by 2 derivative 0 minus x by 2 derivative half. So 0 minus half is minus half. In this manner we can solve these examples. We shall see some more examples from the same exercise next time. So solve the example from question number 7. Thank you.